Good morning and welcome to today's session. Today we are going to discuss topic modeling in text mining. Topic modeling is one of the advanced machine learning approach that we are currently used for natural language processing. This lesson is the continuation of text mining in the previous class. In this session we formally define what is topic modeling and what are the popular methods for topic models, then implementation of the latent Dirichlet allocation in topic modeling. As in the previous lesson, we have defined the topic model like this. A topic model is one of the main ways of organizing text data. It classifies the text body into meaningful classes called topics. The topic models are based on the hypothesis each document is composed of a mixture of topics. That means whatever be the document, it is a resume or a covering letter or even is a leave letter, it contains lot of different words, convey some meaning, and these words all together form different classes or different topics. The popular topic modeling algorithms. The most popular topic modeling algorithms are the latent sentiment analysis or LSA and latent Dirichlet allocation method, that is LDA. Here LSA is the traditional method. It came even before our machine learning era, and so it is make use of the traditional concept of singular value decomposition, the important linear algebraic method. And second one is a probabilistic method, and so it is a modern approach that we are currently using in NLP. First of all, we are going to discuss the latent sentiment analysis or LSA. This LSA is based on distributional hypothesis. This distributional hypothesis says that words and expressions that occur in similar pieces of text will have similar meanings. That means if some words bring together, give some information, if the same words come together in another context, then the meaning always same. It share the meaning. The meaning should be same. That similarity, they try to accommodate the similarity. That similarity means the covariance. If the covariance is minimum, the similarity is more. To collect the covariance, we will use the covariance matrix. That means the singular value decomposition is the best method to make use of covariance matrix. So based on a truncated singular value decomposition with our left singular matrix U as a topic document matrix, and V, the right singular matrix, is the term topic matrix, and the central matrix or singular matrix is actually the covariance matrix. LSA actually try to find out an eigenvalue based approach. We try to find out those eigenvectors corresponding to higher eigenvalues. The eigenvalues of this sigma matrix, the singular matrix. We choose those eigenvectors corresponding to U and V corresponds to the highest eigenvalues of this singular matrix sigma. In addition to that, LSA fix T. T means number of topics. The optimum number of topics in model using a KL divergence algorithm. The Kullback-Leibler divergence algorithm is used to fix this T, the optimum number of topics. If number of topics increases, then automatically the weights will scattered around to different classes, and sometimes the meaning will not be convey. That is another problem. So optimization of this T, the number of topics required to classify the given text data into different classes and convey the proper meaning, we have to fix T. So LSA focused on two ideas. One is classify the words into different topics and also fix the optimum number of topics. The next idea is LDA. LDA stands for Latent Dirichlet Allocation. In this method, we are using a multinomial Dirichlet distribution, and therefore it is a probability based method and is highly mathematical, and we start with a random allocation and random creation of topics, then optimize the word allocation to different topics using the probabilistic approach. So the basic assumptions of LDA are: the LDA assumes documents are produced from a mixture of topics. Again, we assume that there are a lot of different classes of words available in every text document. Those topics then generate words based on their probability distribution. In LDA, we start with the basic idea that the topics will generate weights. Different classes actually generate weights. This is a very similar analogy in our language construction. In every language, sentences are decomposed into different group like nouns, pronouns, adjectives, etc. And from these different classes we take words and join these words, and it creates some meaningful sentences. This procedure is actually known as the grammatical creation or the formal language creation with the help of some automata. This formal language and automata is a very good topic in mathematical analysis and modeling, but that concepts can be replaced with the help of these latent Dirichlet allocation methods. It makes use of the idea that the words are generated by topics. The words can be classified into topics, but LDA says that if we fix find optimum number of topics and the meaning on the rule, the probability rule to construct different topics, then the topics will generate words. Topics will generate words to convey meaning. That is actually thinking like that. We have a collection of containers, and each container contains a special type of words like adjectives, nouns, or something like that. Then we pick different words from these different containers and arrange in a proper manner. That means we follow a distribution. Then it creates a meaningful sentence. That meaningful sentence convey some meaningful information. So LDA is a mathematical model or a machine learning model for language creation or information creation. Steps in LDA. As a first step, we form a document term matrix. Document term matrix is a frequency table. This frequency table contains rows and columns. The rows are documents and columns are terms or words. For example, I have 20 students in my class and I ask everyone to prepare a resume. And so I have 20 documents, that is D1, D2, D3, etc. D20. Then each document contains words. I assume there are m words, W1, W2, etc. Wm. Now this matrix is actually the frequency table. This first element 4 means in document 1, that means in the resume of first student, the word W1 repeats 4 times, like that. This actually a word frequency matrix, that is called document term matrix. It contains two type of information, the document and also the term or word. At the time being, I take n document m words, and therefore this is an n by m matrix. Then next step, LDA generates two submatrices in lower dimension from this DT matrix. We look into that. Step 2, formation of document topic matrix and topic term matrix. Document, topic and topic term matrix. Actually, these matrices are probability matrices. These probabilities are assigned randomly at initial stage. Then it updated in various epochs with the help of some probabilistic learning. We will expand this idea. Calculating the probabilities. We are using two probabilities, P1 and P2. P1 from our first submatrix, P2 from second submatrix. Look into this. This is my document term matrix, topic matrix. This is my topic term matrix. From the document topic matrix, I generate the probability P1, and from T1 W1 I generate another probability or proportional value, that is called P2. I am using this P1 and P2. We simply multiply P1 and P2 and generate new probability. That new probability is assigned to each word, and higher the probability, that particular word is assigned to the corresponding topic. That's all. We explain this idea in very few words. The P1 can be calculated like this. P1 is equal to capital P of T given D. This is the proportion of words in a particular document D that assigns to a topic T. We consider a document, that means the resume of first person, and from that document how many words are assigned to T, that proportion. Suppose from the document D, first person's resume, 5 words are assigned to topic 1, then 5 by number of words in the D1. Suppose it is 200. 5 by 200 is the probability P1. And similarly P2 is equal to P of W given T. It gives the proportion of assignments to topic T. We fix this T, and proportion of assignments of words to T over all documents for a particular word W. That means we fix a particular word. Then we count how many times that word appear in the whole documents. In our example, there are 20 resumes. Education is our word. We scan through all the document how many times education happens. Suppose it is 300 times. So that is how many times this word appeared in all documents. Then we move on to a particular topic. Suppose topic 1, that is qualifications. In qualifications, how many words assigned? This education is assigned to how many times in that particular class education, or qualification. And that proportion, the proportion of assignments to topic T over all documents that come from this fixed word W, that is probability is called P2. Now we have two probabilities, then we multiply these two probabilities, that gives the probability that a particular word is generated by T. We fix the word, that word is generated by a particular topic T, that is equal to P1 into P2. So we can calculate this probability for each word in our text. That means every word has a new probability, a new measure, and based on this measure we classify these words into different topics. That means reallocation will happen. After a certain stage, there is no more reallocation happens. That means our procedure come to an equilibrium, or in other words, the LDA is converges. That is our next step. Finding steady state. After a number of epochs or iterations, a steady state is achieved. That means no more reallocation of words into different topics will not happen. And it is achieved where the document topic and topic term distributions are fairly good. The document topic matrix and also the topic term distributions are fairly good. There is no more change. The distribution is good, means the distribution remains steady, or a mathematical representation or probability becomes steady. This is the convergence point of LDA. Once this happens, the LDA is attained. Now we got an optimum allocation. That means the optimum topics, number of topics will be identified, and the weights are reallocated to the different topics based on our distributions, the latent probability distribution. Now the parameters of LDA. The latent Dirichlet allocation models contains 5 parameters. The first parameter is alpha, that is called document topic density. Second one is beta, that is called topic word density. All these are hyperparameters. Then number of topics, that means how many topics we required. This number of topics is very important. If we ask more topics, that means the words are classified into more subgroups. If the number of topics is a minimum, that means the whole words are distributed into minimum number of classes. The next is number of topic terms. That means how many number of words should be in each topic. If this number of topic terms will be small, that means each topic contains only a fixed number of a small number of words. That's again leads to some missing words. Some words may be exempted from classification. It may happen. And the number of iterations. This number of iterations is also very important. Sufficient number of repetitions necessary. Otherwise, the LDA will not converge. The hyperparameters alpha and beta can be automatically updated in this LDA algorithm implementation in Python. Implementation in Python. In Python, we can use NLTK, that is Natural Language Toolkit, gensim, and PyLDA visualization libraries for document pre-processing, LDA model building, and LDA visualization respectively. That means NLTK is for word processing, eliminating stop words and bring all things together and create a corpus like that. And gensim is a wonderful library, NLTK, a wonderful library for natural language processing that actually contains a lot of algorithms like LSA, LDA, etc. We are using LDA from this gensim library. Then PyLDA visualization, PyLDA Viz is a new library, this latest library. This library helps us to visualize our topic model. This visualization is also interactive. We change a particular topic 1, topic 2, etc., and we can calculate the probability, and it also brings us a PCA. A principal component analysis will provide by that visualization. Whatever words are contribute much to a particular topic, and what is the next dimensional word, like that, all this probability can be comparable with the visualization, the size of the bubble, etc. So this pi LDA visualization is the best tool to visualize the effectiveness of LDA. To what extent this LDA is successful, and we can visualize, or we can show how the weights are classified into different topics effectively to a layman. And also there are different measures to evaluate the model. That models are already available in LDA, but the most important point is the weight distribution of words in each class. We divide different words into different topics, and we assign some weights. That weights gives more insights. If a particular word has higher weight in a particular topic, that means that particular word is assigned to that topic with higher level of confidence. That's the meaning. So this is all about the topic modeling, the theoretical part of topic modeling. Especially we are focused on LDA, because LDA is the probabilistic method. In probabilistic machine learning, we are discussed on Bayesian learning or some type of probabilistic models. So LDA is an important tool for topic modeling. In next session, we will discuss the profiling of text data, how we can profile a particular text corpus into different category, and how we can perceive or squeeze out the latent information from a text data. Thank you very much for the patient listening.